And now we come to the last part of the model. We have a gap missing here. And in fact, I can't actually simply connect this point electrically to this point, or this point electrically to this point, because if I do that, then there'll be no stepping up or stepping down of the voltage or change in the current. So in order to match this circuit to this circuit, we actually finally use an ideal transformer. And the ideal transformer has no internal resistance, no reactance, and no losses, no core losses. So this actually is an ideal transformer. And this transformer will actually do the stepping up or stepping down. So we would have NP turns and NS turns. And the MP to NS is actually the voltage reduction ratio between this part and this part. This actually completes the full model of a transformer. So we have a primary voltage, a secondary voltage, and in fact we would have a primary current, IP, and a secondary current, IS here. We have a representation of the series components, and we said the series components would have the copper losses in the two resistors. The leakage, which is happening here, the leakage in the flux is represented by XP and XS. Then we have the core losses, and it's important to note at this point that here we have a shunt component. So this is actually shunt component. So series component and a shunt component. And in an ideal transformer, we'd like this to be as small as possible. So R and R to be as small as possible, X and X to be as small as possible. And we would like the shunt component to be as large as possible. So shunt component, actually, it should have included these components as well. So all of this actually represents, so this represents the shunt component and this represents the series components. It is effectively as if we're saying that the transformer is actually made of a series part, which is this, and a shunt part, which is this. And to complete the analogy, we will put another series component and a series component. So we can think of these series components as these, and we'd like them to be as small as possible, and a shunt component, which is these core components, and we'd like them to be as small as possible. And in between we have an ideal transformer. This actually completes the equivalent circuit model for a transformer.